the continuity of the given function at a point x is equal to 2, where f of x is equal to x square minus 4 divided by x minus 2 when x is not equal to 2, and the value of the function is 3 when x is equal to 2. Given that at a point 2 the value of the function is 3, therefore we can decide that f of x is defined at a point x is equal to 2. And now to calculate the left hand limit of the function at a point 2, that is bound the function f of x to the left hand points of the neighborhood of a point 2. The left hand points of the neighborhood of a point 2 are in the form of 2 minus h. Put x is equal to 2 minus h. As x tend to 2, replace x by 2 minus h. We have h tend to 0. Therefore, limit f of x when x tend to 2 through the left side of the neighborhood of a point 2 is equal to limit f of 2 minus h, replace x by 2 minus h when h tend to 0. This h represents the left hand points of the neighborhood of a point 2. And we'll substitute the value 2 minus h in the function. We have f of 2 minus is equal to 2 minus h whole square minus 4 divided by 2 minus h minus 2. And after the simplification, the simplest form of this function is limit h tend to 0 to the left side minus h plus 4. Apply limit 2 minus h as well as to the constant 4. Minus 1 multiplied by limit h tend to 0 of h plus limit h tend to 0 through the left side of 4. The limit h tend to 0 of h is equal to 0. 0 multiplied by minus 1 is equal to 0. And the limit of constant 4 is equal to 4. 0 plus 4 is equal to 4. That is, the left hand limit of the function is exist and is equal to 4, which is not equal to plus or minus infinity as calculated. Now, to calculate the right hand limit of the given function, bound the function f of x to the right side points of the neighborhood of a point 2. The right side points of the neighborhood of a point 2 are in the form of 2 plus h. Therefore, we put x is equal to 2 plus h. As x tend to 2, replace x by 2 plus h. 2 plus h tend to 2. And after the simplification, h tend to 0. Therefore, limit f of x when x tend to 2 is equal to limit f of 2 plus h, replace x by 2 plus h when h tend to 0. And replace x by 2 plus h in the given function. We have limit h tend to 0 to the right side 2 plus h whole square minus 4 divided by 2 plus h minus 2. And after the simplification, the simplest form of this function is h plus 4 when limit h tend to 0 to the right side. Apply limit to h as well as to the constant 4. Limit h tend to 0 of h plus limit h tend to 0 of 4. Limit h tend to 0, limit h tend to 0 of h is equal to 0, and the limit of constant 4 is the same constant. 0 plus 4 is equal to 4. That is, the right hand limit of the given function is exist. That is, the right hand limit of the given function is 4 as calculated and is exist. As the left hand limit of the given function is 4 and the right hand limit of the given function is 4, therefore we can decide that the limit of the function f of x at a point 2 is equal to 4 and is decided to exist. As the limit of the function is 4 and the value of the function at a point 2 is equal to 3. That is, the condition between these two numbers is the condition of inequality. Therefore, we can, that is, the limit of the function f of x at a point 2 is not equal to value of the function at a point 2. Therefore, we can decide that the function f of x defined above is discontinuous at a point x is equal to 2.